Let me try to show one possible relationship between the various architecture areas. Everything begins with the strategy. It could be a business strategy at a higher level or even an IT strategy on a domain level. With the strategy, we can devise a business architecture. Business architecture is concerned about what a business does, how it does it, how it is organized, and how it realizes value. It is used to design competitive structures and processes, leverage existing strengths, and identify potential investment opportunities that advance the business's objectives and drive innovation. With the business architecture as a reference and guide, we would start to develop the system architecture. A system architecture is the conceptual model that defines the structure, behavior, and more views of a system. It can consist of system components and the subsystems developed that will work together to implement the overall system. There have been efforts to formalize languages to describe system architecture, which we would cover later. One can think of system architecture as a set of representations of an existing or future system. These representations initially describe a general, high-level functional organization and are progressively refined to more detailed and concrete descriptions. Together with the system architecture, we would need to develop the data or information architecture. A data architecture aims to set data standards for all its data systems, as a vision or a model of the eventual interactions between those data systems. Data architecture consists of models, policies, rules, and standards that govern which data is collected, and how it is stored, arranged, integrated, and put to use in data systems and in organizations. There is a big dependency between data architecture and system architecture. On the other side, we have technology architecture. Technology or technical architecture involves the development of a technical blueprint with regard to the arrangement, interaction, and interdependence of all elements so that system-relevant requirements are met. The focus here is what technology to use to best meet the various architecture constraints presented earlier. Some specialized branch of architecture, like cloud architecture, integration architecture, and infrastructure architecture, belongs to this category. Like data architecture, technology architecture has a tight relationship with system architecture. As organizations evolve, so must the systems. This leads us to solutions architecture. A typical property of solution architecture, in contrast to other flavors of architecture, is that it often seeks to define a solution within the context of a project or initiative. This close association to actual projects and initiatives means that solution architecture is the means to execute or realize a technology strategy or change requirements. Over all these areas, there is also the need for security architecture. Security architecture reflects security domains, the placement of security-relevant elements within the security domains, the interconnections and trust relationships between these elements, and the behavior and interaction between these elements. The security architecture, similar to the system architecture, may be expressed at different levels of abstraction and with different scopes. The higher-level areas like business architecture and IT architecture usually reports into what is commonly known as enterprise architecture. Enterprise architects support an organization's strategic vision by acting to align people, process and technology decisions with actionable goals and objectives that result in quantifiable improvements toward achieving the strategic vision.